Assalamualaikum and hi everyone. My name is Ahmad Nazwan bin Safsazari and my matrix number is AA212085. So today I want to tell you guys about the introduction of our project report. Flip-flop. In the context of electronics, flip-flop refers to a particular type of gate latch. In contrast to a gated latch, a flip-flop does not instantly enable its input when it detects a high signal on the clock input. Instead, the inputs are activated by the transition of the clock inputs. Thus, when the clock input switches from low to high, the inputs are briefly enabled. When the clock stabilizes at the high setting, the flip-flop state is locked until the next clock pulse. Flip-flop are usually referred to as edge triggered since they are triggered by the edge of the clock signal. Edge triggering is a key feature used in clock-driven computer circuits. The clock input is initially low. The inverter makes the NAND gate first input designated 1 high while making the second input low. The output from the NAND gate at point 2 is high because the inputs are not both high. The second inverter flips the NAND gate output, resulting in the circuit at point 3 having a final output that is low, much like the clock input. The second input of the NAND gate immediately turns high when the clock input does. The output from the inverter remains high for those few milliseconds while waiting for the inverter to react, which takes a few milliseconds. As a result, the NAND gate's output at point 2 goes low for a brief period of time when both of its inputs are high. The output at point 3 in the signal briefly goes high as a result of the second NOT gate inversion of the NAND gate output. The NAND gate responds to the low and high input by setting its output to high at point 1. When the first NOT gate catches up and its output changes to low at point 1, the second input of the NAND gate immediately turns high when the clock input does. The output from the inverter remain high for those few milliseconds while waiting for the inverter to react, which takes a few milliseconds. As a result, the NAND gate output at point 2 goes low for a brief period of time when both of its inputs are high. The output at point 3 in the signal briefly goes high as a result of the second NOT gate inversion of the NAND gate output. The NAND gate responds to the low and high input by settings its output high at point 1. When the first NOT gate catches up and its output changes to low at point 1.
Okey, Assalamualaikum warahmatullahi taala wabarakatuh. Nama saya Muhammad Syamizi bin Yusof dan nombor kad matriks saya AA210350. Jadi sekarang ni saya akan membentangkan tentang simulasi menggunakan 3 CAD berdasarkan projek kami, iaitu di mana kami menggunakan 3 flip-flop dan juga 1 gate dan dalam setiap IC yang kami gunakan iaitu IC 74J3, dalam setiap IC terdapat 2 flip-flop. Jadi disebabkan kami memerlukan 3 flip-flop, kami menggunakan 2 IC untuk mendapatkan 3. Jadi kami guna 2 di sini juga 1 di sini dan juga terdapat 1 gate dan untuk terus ni. Jadi kat sini juga kita dapat lihat ada 3 LED yang kita ingin tahu untuk 3 bit LED, iaitu ini ada LED yang pertama, kedua dan juga ketiga. Mana kalau kita buat kat dalam group yang saya akan terangkan nanti, boleh lihat kat sini ya. Jadi kalau saya mula jalankan simulation, kita dapat lihat lampu LED tersebut akan menyala mengikut sequence pulang kami yang kami pilih, iaitu daripada 0 ke 4 ke 2 dan juga seterusnya. Jadi saya akan teruskan pula kepada pembentangan yang seterusnya berkenaan tentang state diagram. Assalamualaikum warahmatullahi taala wabarakatuh, dan sekali lagi saya perkenalkan diri saya, iaitu Muhammad Syahmizi bin Yusof, dan nombor matrik saya AA210350. Jadi saya akan teruskan pembentangan projek kami berkenaan tentang step-step atau langkah-langkah yang diambil untuk menjalankan projek kami, iaitu saya akan menceritakan tentang langkah pertama berkenaan state diagram. Jadi sekuen ataupun susunan yang kami pilih bermula daripada 0 ke 4, dan 4 sambung kepada 2, 2 kepada 6, 6 kepada 1, 1 kepada 5, 5 kepada 3, 3 kepada 7, dan 7 kembali balik kepada 0. Jadi untuk state diagram ni ataupun susunan ini kita boleh lihat daripada kami punya simulation 3 CAD. Boleh lihat daripada LED itu lah. Okay, seterusnya saya akan teruskan kepada langkah kedua berkenaan state table, iaitu yang berkaitan dengan present state dan juga next state, yang berkait juga dengan step ataupun langkah pertama. Jadi dalam table kami terdapat QC, QB, QA, ataupun lebih senang Q3, Q2, Q1 yang boleh lihat daripada kita punya simulation Tinkercad. Jadi dekat dalam table tersebut kita dapat lihat ada binary bit yang kami dah buat daripada segi keadaan LED itu. Yang pertama 000 dan state seterusnya adalah 100. Jadi dia akan langkau kepada state sekarang, iaitu keadaan sekarang 100, dan akan berubah kepada state yang ataupun keadaan seterusnya 010. Dan dalam yang ketiga pula, iaitu keadaan sekarang yang telah berubah tadi 010 dan berubah kepada 110. Seterusnya yang keempat 110 berubah kepada 001. Yang kelima 001 berubah kepada 101. Yang keenam 101 berubah kepada 011. Yang ketujuh 011 berubah kepada 111. Dan yang akhir sekali 111 berubah kepada 000, iaitu keadaan asal bagi diagram ini. Sekian itu daripada saya. Terima kasih.
Hi and Assalamualaikum. My name is Muhammad Farnaman Bezikfli and my number matric AA12042. Now I will continue the present with step 3, which is extension table. By referring to JK flip-flop transition table, Q output is present stage and next stage. Input is JN and KN. As example, if output 0, 0, input is 0x. If output Q output 0 to 1, input is 1x. Another example, if output 1 to 0, input is x1. And another last example is if output 1 to 1, input is x0. Okay, so now we can use the JK flip-flop transition table at step 2 to do extension table. Now percentage and next stage is output, and FFC and FFB and FFA is their input. Okay, now my example is if present state QC is 1 and next state QC is 0, JC will be X and KC will be 1. Another example, if present state QB is 0 and next state QB is 0, JB will be 0 and KB will be X. And lastly, if present state QA is 0 and next state QA is 1, FFA will be JA1 and KAX. That's all for me. Thank you.
Assalamualaikum. My name is Putra Muhammad Raiman bin Muhammad Tua. My matric number is AA211352. I will continue the presentation for the step 4, which is KMM. At the FFC, the J input we have 2, and we should sum all the input in J, and we can get JC equal to QB exclusive QA. For the K input, we also have to, and we also have to sum all the SOP, and the answer for the KC is equal to QB exclusive QA bar. So for the FFB, the J input, we use group 1 together for the together K map. So the answer is J2 equal to QC and QB bar. For the K input, we use don't care condition, so we have to, and we should sum all SOP, and the answer for K2 is equal to QC exclusive QA bar. And for the last is FFA. For the J input, we use group 1 together, and the answer for the J1 is QA bar. For the K input, we also have 1, and the K1 answer is QA. And for the last step, which is step 5, is a circuit implementation. We should do the circuit from the K map. At the flip-flop A, J1 connect to Q1 bar, and K1 connect to Q1. Next, at the flip-flop B, J2 has AND gate and connect to Q3, and Q2 bar and KT and K2 have XNOR gate. It connect to Q3 and Q1. Last, at flip-flop C, Q3 has XNOR gate and connect it to Q2 and Q1. And for K3 also has XNOR gate and connect it to Q2 and Q1. And the clock for 3 flip-flop should combine to 1 clock. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Nazim Samsazari, and my message number is AA212085. So basically, I will be presenting for project test B, which is parallel in shift register using 7476 JK flip-flop and the simulation by using the Logisim software. So from the question that asks to construct a 4-bit parallel and recalculating shape register circuit as shown in figure 2. This is currently what shows in figure 2. So as we can see from the table, we have line number 1 until 15. So we have input A, B, C, D, clear and clock pulse, and the output, which is FFA, FFB, FFC, and FFD. So for the line number 1, we get the clear 1 and the parallel load ABCD 1 1 1 1, and clock pulse will be 1. The output will be 0 0 0 0. And for the line number 2, the inputs clear 0 and the parallel load 1 1 1 1. The outputs will be 0 0 0 0. And for the line number 3, the inputs clear will be 1 and the parallel load ABCD will be 1 0 1 1, and the outputs will be 0 1 0 0. And for the line number 3, the clear will be 1, parallel load A B C D will be 1 1 0 1 1, and the output will be 0 1 0 0. For the line number 4, the clear is 1 and the parallel load A B C D 1 1 1 1, and the clock pulse will be 1. The output will be 0 0 1 0, By the way, the input for line number 4, 5, 6, 7, 8 is the same, but the output will be the different, and the output for line number 5 is 0001. For line number 6 is 1000. For line number 7 is 0100, and for line number 8 is 0010. For line number 9, the input at clear will be 0111, and the output will be 0000. For line number 10, clear 1, parallel load 1001, and the output will be 010100. And line number 11, 12, 13, 14, 15, the inputs will be the same, and the clock pulse will be different, and the input is 1111, and the output will be 0011. That's for the line 11. For the line 12, the output will be 1001, and for the output for the number 13, the output will be 1100, and yeah, the number 14, the output will be 0110, and for the line 15, the output will be 0011. Yeah. So that's our simulation. Basically, we just put the input in the software, and we will get the output just like the table. Just put input in the clock pulse and clear. We put input in the parallel load and run, and then we get the output. We get the output for the in. That's all from me. Thank you.